Alright guys, today's lesson is going to be over equivalent expressions. So we've talked about parts of an expression, we've talked about writing expressions, and we've talked about evaluating expressions. Now we're going to talk about finding equivalent expressions. Okay, equivalent means equal, so we're going to be finding expressions that are equal to one another. Okay. So to do that, we're going to have different properties, okay? We're going to have the associative property, the commutative property, and the distributive property. And we're going to have different examples of each property so that you can see what these look like, okay? The associative property is when you move parentheses from one side to the other. Like when you associative, you hear the word associate, which means hang out with. So it's like when you group numbers with parentheses, if you group numbers this one way and then you move and can group them the other way and they're equal to each other, then that's called the associative property. Commutative property, you hear the word commute in there, that means to move. Okay, so you can move the numbers around and they're going to equal the same thing. The distributive property is when you have a set of numbers in parentheses and you have a number outside of the parentheses and you multiply the outside number by the number inside the parentheses. So here we're going to see an example. It says, what is an algebraic expression that is equivalent to the expression below? It says so what we're going to do is we're going to use the properties to find an expression that is equivalent to this, okay? So to do that, basically we're going to be simplifying this. So we've got 4 times 6x plus 9 minus x. See how we have this 4 sitting outside these parentheses? We're going to distribute or multiply that number into each term inside the parentheses. So we're going to do 4. So we're going to have 4 times 6x plus 4 times 9. Okay, we don't want to forget to bring down our minus x. So 4 times 6x. That x is glued to the 6, so he just stays there. So what's 4 times 6? 24. So we've got 24x plus 4 times 9 is 36. Bring down our minus x. All right, so that was the distributive property. We notice that we have x's here still. Do we know what's in front of this just x right here? There's an invisible 1 in front of that x. So what we can do is what we call combine like terms. And in order to combine like terms, we're going to use the commutative property and move these numbers. So we're going to use 24x minus 1x plus 36. So now we can simplify 24x minus 1x. We're going to combine those like terms and combine them together. 24 minus 1 gives me 23x. We've used that, so we're going to get rid of it, and we're going to bring down 36. Now, we can't do anything with that 36. We can't combine it with 23 because it doesn't have a variable. It doesn't have that x variable there. So that's as far as we can go. So 23x plus 36 is actually equal to that expression right there. Okay? All right, let's see another example here. Okay. All right. It says, which of the following expressions is equivalent to 5a? We have to ask ourselves, what is taking place? What is going on when the number is next to a letter? What operation? Are we adding, subtracting, multiplying, or dividing? We're multiplying. We're saying 5 times a. Is that an option here? Well, no, it's not, okay? So we have to think, what does 5 times a mean? That means we have 5 groups of a. That means we're adding, multiplication is repeated addition. We're adding a 5 times. So which one of these is adding a 5 times? B, correct. Now C, we have A times A times A times A times A. That's going to be A to the 5th power, and that's not what we're looking for. So B would be the correct answer. All right, let's look at this final one right here. It says, which of the following expressions are equivalent? So which ones are these going to be equal to each other? All right, so your first gut reaction is probably these two right here. Okay, what did they change? They moved the variables, didn't they? We can't do that because what you can do, a trick here, is give those variables a value and plug it in for us. So let's say x equals 2 and y equals 1. Okay, so 15, substitute x for 2 plus 27 times 1. 15 times 2 is going to be 30 plus 27 is going to give me 57. All right, so let's plug it in here. Y is 1, so it's going to be 15 times 1 plus 27 times 2. 15 times 1 is going to be 15. 27 times 2 is going to be 54. When we add those together, we're going to get 69. Do those two equal each other? They do not, so we can cancel those out. All right, so let's try this. So we're going to have x equal 2 and y equal 1. Okay, so let's plug that in. So let's leave those. These two did not match. So we had, all right, so let's say 3 times 5 times 2 plus 9 times 1. All right, order of operations say we look at the parentheses first. 5 times 2 is 10. 9 times 1 is 1. Okay, we're going to add those together and we're going to get 19. So we're going to have 3 times 19. Okay, 3 times 19. So I can't do that in my head, so I'm going to multiply it like this. 9 times 7, 9 times 7, 9 times 3 is 27. 3 times 1 is 3, plus 2 is 5, which was 57. Do you remember that's what we got for A? So it looks like these two are going to be equal to each other. Okay, let's just finish up with D. We have 42, plug in x for 2 and y for 1. All right, 2 plus 1 is 3. 3 times 42, so we're going to write it over here. So we have 6, 1 times 3 is 12, and that's not right. So we know that 126 isn't equal to any of the other problems. So the only ones that are equivalent to each other are C and A. So that's going to end up being our answer. All right, let's jump over real quick to some practice questions. Let's see if I can find it for us. So we're going to hit finish. Oh, no. All right, so let's look at these examples right here. It says, which algebraic expression is equivalent to the expression below? Now, remember we have order of operations. Please excuse my dear Aunt Sally. Okay? Those are in parentheses. 9x minus 11 plus 11 are in parentheses. So, but we can't do anything with it, can we? We've got 9x minus 11 plus 11. Okay? You can't combine these two because they're not like terms. So, in reality, we're going to use our commutative property, and we're going to rearrange our numbers because we don't know how to do negative 11 plus 11. But we do know how to do plus 11 minus 11. Okay? So 11 minus 11 is going to give us 0. So we have 9x plus 0. Which one of these is going to be equal to that? So it's going to be C. Let's see if we got it right. Yay, we got it right. All right. So we had to use the associative property, not the associative, the commutative property to rearrange these numbers. Let's look at another example. All right, we're going to try to find an equivalent expression here. So the first thing we see parentheses and we see a number outside of it. So we need to be thinking of the distributive property. Remember, with the distributive property, we're going to get the multiply it next to each other. So now we've got 3 times 12k plus 3 times 4 plus 6k. All right, we're going to do our multiplication here. 3 times 12 is 36k plus 3 times 4 is 12 plus 6k. We notice if we box these in right here, okay, that we have two terms that have the same variable in it, so we can combine those. So using the commutative property, we're going to rearrange it to where we have 36k plus 6k plus 12. 36 plus 6 is going to give me 42k. So we combine this. We don't need those anymore. Bring down our plus 12. We can't combine these two terms because 12 doesn't have a variable. So our final answer looks like it's going to be D. Let's see if we're right. And we're right. All right, let's do another with each other. All right. Once again, we have parentheses, and we can't combine those two terms because they're not like terms. They don't have a variable. So we can basically get rid of those parentheses. And so we have 12 plus 2t minus 2t. We know that 2t minus 2t is 0 plus 12, which we know equals 12. So that one was too easy for us. All right, maybe the next one will be a little more. There we go. That's what I'm looking for. All right. Are the two expressions equivalent? We've got, in parentheses, 2k plus 9 plus 7k plus 10k. And then we've got 9k plus 19. So we're going to simplify these and see if they are equivalent. Okay? So all of our answer choices, if we look, have us plugging in 3 for k. 3 for k. So let's see if we do that. If we substitute 3 for k. So I'm going to have 2 times 3 plus 9 plus parentheses 7. Oops, I was about to put k again. Plus 3 plus 10. All right. According to our order of operations, please excuse my dear Aunt Sally. We're going to do parentheses first. So in parentheses first, if we follow inside the parentheses, we still have to follow order of operations. We don't have exponents, but we have multiplication before we have addition and subtraction. So 2 times 3 is 6 plus 9. Okay. And then we have 7 times 3 is 21 plus 10. Now we can combine those. 6 plus 9 is 15. Plus 21 plus 10 is 31, which gives us a total of 46. Okay? That's expression A. Let's look at expression B if we substitute k for 3. 9 times 3 plus 19. 9 times 3 is 27 plus 19, okay? Let's do standard algorithm here. All right, 7 plus 9 is 16, my bad. 2 plus 1 is 3 plus 1 more is 4. We have 46 and 46. So are they equivalent? Yes, so we can get rid of these no answers. All right, so let's look at this explanation here. Yes, because for k equals 3, the value of expression a is 84. Is that the answer we got? No. Okay. Yes, because for k equals 3, the expression a is 46 and the expression b is 46. Yes, it's correct. So our answer has to be D. Notice how I looked at the answer choices before I solved it. And yeah, it gave me a value for 3, which made it so much easier. Okay? So make sure you do that. Let's make sure we're right. Very good. We're correct. All right. We're going to stop here. If you want to try and solve this problem, you are more than welcome to, but we're going to stop here. And I'll let you get to some practice.